Okay, so graphing quadratics. Guys, this information is so important. So, quadratic function. We've already talked about it. It's in this form, but now we're adding on y equals. Okay, and the a value can't be 0. Parabola. That's what the graph of the quadratic function is. It's a U-shaped, whether it's upside down or right side up or upside down. Quadratic parent graph. This is the parent graph. Okay? Axis of symmetry. The parabola, okay, so if I look over here, this point right here, that is called the vertex, and the vertical line that cuts it in half is called the axis of symmetry, because everything that's on this side is also on this side. So it's symmetrical. This point right here, that would be a minimum point. If it's up here, this would be a maximum point. The vertex is the point where it changes direction. The zeros are the x-intercepts. They're also sometimes called roots. And it's when y is equal to 0. So this point I should do it different color. This point right here and this point right there, those are the zeros. It's where y is equal to 0. Okay, so we're going to look at this. Okay, key points. So the very first thing asks for the axis of symmetry. This line right here. X equals, and what does it go through? It goes through -2. The vertex point, where did it change direction? The x is at 2. Right here, the x is at 2. The y is at 8. The y-intercept, so that's when x is equal to 0. I should change the color right here. I should make it this color. That is 0, 4. The y-intercept, so it hits here and it hits here. We're guessing that it's evenly distributed. So 1, 0, -5, 0. So 1, 0, -5, 0. Then, as x increases, so we're going this direction, the y value is going this direction. So it decreases. Okay, then it says x decreases, so as the x goes this direction, what is the y doing? It's also going down. Okay, this one over here. Okay, axis of symmetry. Okay, so x equals +2. The vertex is this point that's right here, and that is the point 2, 16. So 2, 16. The y-intercept, IV, is right here. So that's the point 0, 12. Then it says the x-intercepts right here and right here. So that's the point -2, 0, and 6, 0. Again, as the x's are getting bigger, the y's are getting smaller, so they decrease. As the x's get smaller, the y's are also getting smaller. Okay. Awesome. This one, axis of symmetry. Right here, x is equal to 0. This point right here, That is the point 0, 3. Y-intercept, look at that. It's also the y-intercept. Doesn't hit the x-axis. So there are no zeros. And then as we're going to do this point. As x is getting bigger, y is getting higher. As x is getting smaller, y is getting bigger. So these are both increases. Notice how these are the exact same. Okay, axis of symmetry. X is equal to negative 3. My vertex point, right there. So that's negative 3, 3. My y-intercept is right here at 12, 0. Okay, and then my x-intercept. We don't have an x-intercept. As the x gets bigger, the y gets bigger. As the x gets smaller, the y gets bigger. So this is both increases. Okay. So, standard form. Okay, we've talked about this already. We're just adding on either f of x or y. Remember, they're the same thing. Okay, what's the a value? What's the b value? What's the c value? So, graphing quadratic functions. Okay, here we go. So, find the axis of symmetry. Negative b over 2a. So I'm going to come down here and do this right here. A is equal to 1, B is equal to 2, C is equal to negative 6. So in order to find this, it's negative B, so negative 2 over 2 times A. So that'll get me negative 2 over 2, which is negative 1. So x equals negative 1. Then it says, find the vertex and determine whether it is a maximum or a minimum. Okay. Well, hello. Come on. So the vertex, if you notice on each one of these with the vertices, or the vertex on each one, the x value here and the x value here, the x value here and the x value here, they're the same. So that means, so if I was to graph x equals negative 1, that's going to be here. Okay? Then my vertex, I'm going to take that negative 1 and I'm going to plug it in. So I have the equation f of negative 1 equals negative 1 squared plus 2 times negative 1 minus 6. So that's going to get me 1 minus 2 minus 6. So my vertex is going to be negative 1, and that's going to be negative 7. Negative 1, negative 7. So that point is right here. Y-intercept. That means that I'm going to plug in 0. I'm going to plug in 0 for the x values. So 0 squared plus 2 times 0 minus 6. That will get me negative 6. So the point 0, negative 6. 0, negative 6. Okay, now, this is the line of symmetry. So if I have 0, -6, if I have, I'm going to do this. So I have the point -1, -7. I have the point 0, -6. So this is the in between. So whatever's above and below, they have to be the same numbers. So -2, that means that this is also -6. So this is going to also be -6. So then I'm going to plug in 1. And whatever I get for 1, it's going to be the same for -3. So let's plug in 1. If I was to plug in f of 1, I would get 1 squared plus 2 times 1 minus 6. So f of 1 equals 1 plus 2 minus 6. So f of 1 equals -3. So this is -3, this is -3. So -3, -3 is going to be here. 1, -3 is going to be right there. Now, could I do more points? I could, but I don't need to. There we go. Which way did it go? It goes up. So this one over here. Again, -b over 2a. So my -b, I should do this. A is equal to 2, B is equal to -8, and C is equal to 2. So -b, that's going to get me 8 over 2 times 2. So 8 over 4, so I have 2. So x equals 2. So that's my axis of symmetry. Then my vertex, that means the x value is 2 for my vertex. So f of 2 equals 2 times 2 squared minus 8 times 2 plus 2. A lot of 2's on this one. So that's going to get me 2 times 4 minus 16 plus 2. It's going to get me 8 minus 14. So f of 2 is going to get me -6. So 2, -6. 2, -6, that point right there. Then I need to do my y-intercept. So f of 0 equals 2 times 0 squared minus 8 times 0 plus 2. This will turn to 0, this will turn to 0, so I just have 2. So 0, 2. So if that is my y-intercept, that means this right here is symmetric to that. So I don't know, do you want to plug in a -2? I'm going to plug in a -2. F of -2 equals 2 times -2 squared minus 8 times -2 plus 2. Is it plus 2? Yes. So f of -2 equals 2 times 4 plus 16 plus 2. 8 plus 18. Oh, that's going to be way off. 26. Oh, yeah. I do not have the space for that. So let's plug in -1. Or no, let's plug in positive. Why did I plug in -2? Okay. I'm just going to plug in 1. How about that? 2 times 1 squared minus 8 times 1 plus 2. So f of 1 equals 2 minus 8 plus 2. So that's going to get me -4. So this goes here, and I can draw my parabola. There we have it. Okay, a catapult. In 1304, Edward I built Warwolf, one of the largest catapults ever used in battle. It had a capacity to launch 300-pound boulder over 900 feet. The height of the projectile launched for the Warwolf can be modeled by that equation, where h of x represents the height in feet of the projectile after x seconds. So we need the information. So my A value is -16, my B value is 96, and my C value is 40. So negative B over 2A, so x equals, that's going to be 96 over 2 times -16. So that'll be 96 over -32, which will be -3. So over here, oh, I forgot the negative for the negative b. That's +3. Well, look at that. There we go. Then, if I was to plug in -3, so h of -3, no, why Kim? +3, not -3. H of 3 equals -16t3 squared plus 96 times 3 plus 40. So h of 3 equals -16 times 9 plus 288 plus 40. So h of 3 equals, that's a -144 plus, that's an 8, that's a 2, that 328. So h of 3 equals 184. I think that's the point. Oh, let's see. That looks about it. Okay, and then when x is equal to 0, oh, this is h of x. So that's going to be -16 times 0 squared. It's going to be plus 96 times 0 plus 40. So h of 0 is equal to 40. So that's the point 40, or 0, 40. How'd we do? 0, 40. And then this is going to be 6 point something. Okay, what do they mean? Well, the intercepts. The x-intercept is where it's on the ground. The y-intercept, when launched, what are we launching? Boulder. When the boulder leaves the catapult. The vertex point is when the boulder starts to fall. When is it increasing? It increases from here to here. So when x, between x is 0 to 3. When is it decreasing? That's this part right here. So it's when it's between 3 and 6 point, not sure. Okay, what is my in behavior? So as x increases, y decreases. As x decreases, y decreases, because it's upside down. The domain, guys, the domain, from where to where? It can go from 0 and it ends at 6 point something. The range, the lowest it can be is 0. The highest it got was, what was the vertex? 184 feet.